another example on method of substitution, guys. This one is going to be slightly different than the other ones that we have seen so far. So let us start working on this one. Again, we know we have to follow those 3 steps. Step 1 is we have to choose a particular function, and then we have to substitute it and then go from there. So guys, step 1 is to let u equals to, so in this case, again, we got to use the function that has an exponent with it. Obviously, you can see that the function in the denominator has an exponent. Wait a minute, even before doing that, guys, what I want to do is I want to rewrite this function, and I'm not going to disobey any of the mathematical rules. So can I write this as, or rewrite this as, I'm going to bring this expression in the denominator upstairs. So if I bring it upstairs, then what happens to the exponent? The positive exponent obviously changes to a negative exponent. So let me actually do that first before I start the substitution step. So I'm going to rewrite it like this. I think this will help us when we start simplifying things. So now I'm going to substitute u equals to x minus 5 because it has an exponent, and we usually like to start with those as substitution pieces. U equals to x minus 5. Then step number 2, guys, is going to be you have to find the derivative of this function with respect to x and then solve for dx. So let us do that. So du over dx, in this case derivative of x is 1, that is constant, so it implies that in this case dx is simply du. Okay, that is slightly different than what we have been obtaining in our previous examples, but let us see what happens next. So in the next step, step number 3 is kind of bringing this back together and substituting for values. So here let us use this expression rather than using this expression. I mean, if you like to work with this, that is fine, but I think this is going to make our life a little easier. Okay, so I have 2x, right? I don't usually do anything with that x, and then x minus 5 inside the parentheses is going to be u, right? It is, we already know that it's u to the power, don't forget there's a negative 2, and then dx is simply du in this case, right? So guys, this is where this example is different than the other examples, and if you have been watching my other examples and watching my videos, you already know that at this step x's go away and we're only left with function in terms of u, and we are integrating with respect to u as well. So in this case we have this x is still left, and we cannot really integrate this because there's an x variable and there's a u variable, and then we are trying to integrate with respect to u, so we cannot really do it without when we have 2 variables here. Okay, so we have to figure out something to actually simplify this so that we can evaluate the integral. And we should know that if we get this x in terms of u, our problem is actually solved, then everything is consistent in terms of u, and then we will be able to actually evaluate this integral. Now let us go back and look at our substitution method, the first step, and see if there's a way for us to write x in terms of u. Okay, so if I look at this expression right here, then from this expression we can solve for x, and if I solve for x, x would be simply u plus 5. And then if I bring it back here, and if I substitute it right here, see what happens. I have a 2. Well, let's not worry about that 2, and let us already bring that 2 outside, because anyway that's what we were going to do with that 2. X, guys, we can replace by u plus 5 in parentheses. It's a binomial, we got to keep it in parentheses, and then there's u to the power negative 2 and du. Guys, now everything is in terms of u. Nice and fine. So I think now we should be able to evaluate the integral. So guys, this is what is unique about this example, that there are times when the x quantities may not cross out. So if they do not cross out, then we have to go back to the step number 1 and see if we can solve for that x or whatever is in this step, and then see if we can solve that variable for in terms of u. And here in this case we were able to solve it in terms of u. We bring it back here, or we kind of substitute it back here, and then we look at this expression and we ask ourselves, now can I actually find or evaluate the integral? And the answer to that is yes, but we may have to do some steps in order to actually integrate or evaluate this integral. So guys, the steps would look something like this. I would like to rewrite this as, let's take it up here so we have enough space. So guys, I'm going to put that 2 outside, then there's integral. Guys, I'm going to rearrange this a little bit. I'm going to write u to the power negative 2 up front, and then u plus 5 next, so that it is easier for us to actually multiply or distribute here. So after this step, again, we cannot directly write the integral of this. We have to do some extra work, which is not too difficult. So guys, you got to first distribute this. Let us do that. So if I multiply this, of course there's an invisible 1 here. When I multiply these, it will be negative 2 plus 1, that would be negative 1, and then this would be simply 5u to the power negative 2. Of course there's a du here. Okay, so we distributed this. Now from here we would like to break it into two pieces. I'm going to leave the 2 outside, and then let me put a parenthesis here because I know this 2 is multiplied to this whole thing. So guys, this square bracket like reminds me that it's going to be multiplied to both the pieces, although I'm breaking those two pieces, like breaking this function into two pieces. So it's going to be u to the power negative 1 du, and then of course I have a 5 u to the power negative 2 du. Okay, leaving that 2 outside, then integral of this, again, this we cannot use a power rule on this because it has an exponent negative 1, but we already have a rule for this, and we know this is going to be the ln of, we like to put it in the absolute values of u, right? This is something we already know, it's in our rules. And then plus, guys, 5, I don't have to worry about that 5, I take the 5 out, and then I have to take the derivative integral of this, and integral of this can be evaluated using the power rule, which is u to the power negative 2 plus 1, which is negative 1 over negative 1, and of course there's a plus c, which we have to put all the way at the end. And then let us simplify, guys. This 2 has to be distributed with the first term and the second term, so it's going to look like 2 ln of u minus, because this negative goes up here, so it becomes negative 5. Negative 5 times 2 is negative 10 u to the power negative 1 plus c. We're almost done, but all we have to do is we have to go back to step number 1, and we have to substitute the u with the corresponding x values, which we have started with. So it's going to be 2 ln of, instead of u, I'm going to write x minus 5. We have to have the final answer in terms of x because the original function is also in terms of x. And then minus 10, and u is again x minus 5 raised to power negative 1 plus c. This, guys, is the final integral for this expression. Yes, this was slightly different than any of the examples that we saw previously, but again, guys, the key is to follow those 3 steps. And then at step 3, if you don't get only one variable, if the final final expression is not only in terms of one variable, then you go back to step number 1 and see if step number 1 can help us to get this step 3 in only one variable. In this case, it was able to help us to transform step 3 in one variable, which we did. After that, we were able to see that we can distribute things, and then we broke it into two pieces. We knew some of the rules like the power rule and the rule for finding the integral of an inverse function. We used those, bring it all together, at the end substitute the u back, and here we have the integral for this function. Okay, so guys, these are this is example 10. I'm probably going to show you some more examples on substitution, and then we're going to move into some other methods as well. Okay, guys, I also want to show you, like, so far we have only been doing indefinite integrals where we get a constant of integration. We'll also now learn a definite integrals where we'll have a limit, a lower limit and an upper limit. Okay, as you already know that the idea of this integration is about evaluating or finding the area under the curve, and now when we talk about the definite integrals, it actually will make more sense because we will have a lower limit and an upper limit, and based on that we'll be able to evaluate the integrals. Okay, guys, keep practicing these. If you need any help, let me know, and till then, take care. I will see you in the next video.